before we start, just have to let you know that a sequence in general is a list of numbers that may form a pattern. There are some sequences that are just lists of numbers that don't really have a specific pattern. We saw those when we were talking about domain and range and things like that. Sometimes there wasn't any rhyme or reason to the numbers that were in there, but sometimes we have these sequences that do form a pattern. And today we're going to talk about arithmetic sequences. And that word looks like arithmetic. It is, but when you use it to describe a sequence, you can call it arithmetic. So in order to introduce this, I want to look at this example here. So an arithmetic sequence, as you can see, is a sequence that has a common difference between each term. So for instance, if we look at this example above here with this table, we have time in seconds and distance in miles. This particular example talks about during a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until the time you hear the thunder. So that's what this table represents. And you can see as we go down, as they've labeled here, from in 1 second difference, you're 0.2 miles away. In 2 seconds, you're 0.4 miles away. So you can see that as you go down, the common difference here is we're just adding 0.2 for every second that's there. The other way that we could list this would be horizontally. So I could go 0.2, 0.4, 0.6, and so forth, and keep listing those. That would be how you would see a sequence. Now, sequences can be graphed as well, as we saw with domain and range and all that. So this could be put onto a graph, and I'll show you what that looks like in the second video here. But at this point, we just need to know if we have an arithmetic sequence or not. And how do you find out the next terms and all that? Well, you need to know what your common difference is. We've already discussed that the common difference is plus 0.2. So you're adding 0.2 every time in between those sequence, or in between those terms. So if it's listed horizontally, this is your first term, your second term, your third, and then so forth. So let's take a look at a couple examples here. So first, what I want us to do is determine for these examples, are they arithmetic or not? And if they are arithmetic, let's find the next three terms. So let's look at A. So we're looking for a common difference between each term. So I'm going to be looking here in between each term. To get from 2 to 4, I'm adding 2. 4 to 6, adding 2. 6 to 8, adding 2. We have a common difference. Yes, this is arithmetic. I'm going to abbreviate. So that one is arithmetic. B, that is not going to be arithmetic. There is a pattern. You're going to double each time. But notice how the pattern, the pattern is 1 times 2 gives me 2. 2 times 2 gives me 4. 4 times 2 gives me 8. So there's a pattern, but it is not arithmetic. Alright, so if we check out C, looks like this is decreasing, and that's okay. A common difference can decrease as well. So let's see, from -2 to -5, we are subtracting 3. From -5 to -8, we are also subtracting 3. From -8 to -11, we are subtracting 3. This is arithmetic. D has a couple different pattern options that you could follow. These are all your perfect squares. So for instance, 1 squared, 2 squared, 3 squared, 4 squared. You can also think of it as adding all the odd numbers. So +3, +5, +7. So not a common difference, meaning D is not going to be arithmetic, so not. And then lastly, if you ever see your sequence fluctuate from negative to positive, it's probably not going to be arithmetic. In fact, it won't be, because in order to change the sign of a number, you have to multiply it by a negative. So this has a pattern again. You're multiplying by -2 each time, but it is not arithmetic. All right? And the only other thing you have to do, if it is arithmetic, is use that common difference to get your next three terms. So at the top for A, I would just add 2, or 8 to 2, or 2 to 8, sorry, you get 10, 10 plus 2, and 12 plus 2. So those are my next three terms. On the bottom, we would just keep subtracting 3. So to go negative 14, negative 17, and negative 20. Those would be my next three terms. So that's how you determine if it's arithmetic and how you find the next three terms. And that's all I've got for this one.